Yeah. Did you have a question? Getting started?
Yes. Sorry. Can you show one more time?
Yeah. So on my machine, so I'm pretending over here. I'm pretending. So first you have to navigate to your directory that has the notebooks. Okay. So in mine, I changed into 2022-FA for fall stats 21. That's where I have it saved. And once you are in that directory, and assuming everything else is set up, you can just do git pull upstream main, and that will reach out to GitHub and pull that repository. And then once you have that running, or once you've done that, you can do Jupyter Lab, and it will open it up. Okay. So from the console, you would type in Jupyter Lab. Yeah.
So I don't know. So if I'm using Git bash to do the git pull upstream main, would I have to do the Jupyter Lab?
Yeah, you'd have to do Jupyter Lab, and so if you're on a Windows machine and you use git bash for git pull upstream main, that's one thing, and then you have to open up a separate window to do. You have to open up your Anaconda prompt, because I think Anaconda prompt loads variables into kind of the environment path, which doesn't exist in git bash. So you have to do Jupyter Lab in Anaconda prompt. Yeah, it's a little. It's a tiny bit annoying on a Windows machine, but that's, alas, that is sometimes how it goes. Okay, so yeah, I've started up Jupyter Lab up here, and now it's running, and I have this open. And just to address, this is my daughter Eva, and she is. There was no school today, and couldn't find a babysitter in time, so she is joining me here, and so she's here. She's 5, and anyway, we're. That's that. Okay. Her older sister's also here, but I left her in my office. She's probably playing Minecraft or something. Okay. So anyway, let's take a look. This is lecture 2-2, and we'll talk about flow control. So flow control is basically how do you control the flow of execution in your code, right? And so this includes things like your if and else statements, so that you can kind of execute certain blocks but not others, and then also things like your for loops and stuff like that. Okay, so we'll take a look, and then if we get through that, we'll also introduce lists. And I'm not sure how far we'll get, so I have this spilling over into our next lesson. Okay, so one of the most basic things is the conditional statement, right? And we have the if, the else if, which is elif, and else. Okay, and this is it, right? A couple things to note is you don't need to specify parentheses. You can just do stuff like if x equals to 0, if x is equal to 0, you put a colon after your conditional statement, and then you have to indent lines to associate it with the conditional statement. Okay, so lines indented after the colon are associated with that if statement or that conditional statement. When there's no longer indentation, then those lines are no longer associated with the if statement. And so it's very important that you get your levels of indent correct. Now, do we use tabs or spaces? So I think my default is 4 spaces for a tab, but I think it accepts as small as 2 spaces. Let me kind of double check. If I do, oh no, I guess it doesn't like 2. So 4 spaces. Okay, so you can, and I think in Jupyter the default is when you hit tab, I think it just inserts 4 spaces. So when you hit tab, it's inserting 4 spaces into your thing. And so if you needed to, you can kind of you can do that. Okay. So anyway, here I set x equal to -3, and then I have if x equals 0. So this is our first conditional statement, and we're going to print the x value, and we're going to say along with the character string is 0. Okay, and then I have and then I remove the indentation, and I have else if if x is, so if this is not true, then we will execute the else if. Okay, and I have x greater than 0, and if that's the case, then it's going to print out the number x, and it's going to say is positive. And if it's not 0 and if it's not positive, then it must be negative. At least that's how it works for real numbers, as far as I know. Okay, and here we have x must be negative. And so if I run through this, it goes, it checks off x -3, and then it prints out x must be negative. Yes, question?
So what if we want to write a number but have no space? Between the number and the space?
Yeah, you can do, if you wanted the number but no space, I think you can do separator equals blank, right? And then you can do that, okay? Yeah. The default separator is a space character, but you can change that. So there's always options, and you can always look up show contextual help, and here it can print. You can see the default here is the space, and you can change it, right? So I like JupyterLab, and you've got some of these nice features. You can right-click things and ask for help. Okay, here I'm executing the same exact, not the same exact code. Here I've got x equal to 100, and I have if x is greater than 0, we're going to print x is positive. And then I have this statement, and I said else if x greater than 3, print x is greater than 3. Otherwise, print x is 0 or negative. And this statement will never get executed, ever, because this condition is only checked when this is false, right? So if this turns out to be false, x greater than 0 turns out to be false, then it will check this condition, and then it will check this condition, and then otherwise it'll just execute this. Now this condition, x greater than 3, will never be true when at the same time this is false, right? And so this will just never get this condition, or not this condition, this statement will never get executed, because there's no situation where x greater than 3 is true, but x greater than 0 is false. And so in this case, when you run x equal to 100, it is greater than 3, but it's going to just print out x is positive, and then once it, in kind of this if else block, once one of those things is true, if the if statement is true, it's going to ignore everything else, okay? Or if the else if statement is true, it's going to ignore the else, and so on and so forth. Okay, you can nest conditionals, right? But nesting conditionals can become hard to read, and generally it's recommended to avoid it if possible. So here I have x equal to 5. We're going to say if 0 is less than x, okay, or if x is greater than 0, you can also check if x is less than 10, and if these are true, then we'll say print x is a positive single digit number. I guess that's not necessarily true, because I could have like 5.1. So I guess there should be a condition like if x is an integer. But anyway, we'll say x is 5. If it's if you have a integer between 0 and 10, it's got to be a single positive thing. And so this is a thing, right? We could do this if 0 is less than x and x is less than 10, or if you can do if x is greater than 0, you can also do this if x greater than 0 and x less than 10. That's fine, right? And I can also do and type x equals to int Oh wait. Hold on. That was not true. Let me see. Type x. It is int. How do I? Okay. I think it's is int. Is that the thing?
I think you just do type x equals int, like without the quotations.
Oh, without the quotations? Is that what I'm supposed to do? Type equals x equals int. Okay, that's true. That's what I wanted to do. Right. So I can do type x, thank you, equal int, right? So we can kind of do this. If x is greater than 0 and x is less than 10 and type of x is equal to int, then this will be true, right? So we can kind of link a bunch of these things. And then and is a keyword and it's all lowercase. And if you got, Python can express kind of some of these mathematical inequality sets, and we can do, if 0 is less than x less than 10, and that's even kind of more concise than that. Okay. Okay. So we have that for your conditional statements. All right. For recursion. So recursion is kind of a weird thing. But technically, you don't need to do, you can have like a Turing complete language without for loops or anything like that. And you can just kind of do things recursively. Now, it gets annoying. But when you write a recursive function, you basically make a call to the function that you're defining within the function itself. Okay? So it's kind of like, you're giving somebody instructions, and the instructions are basically like, and then do it again, okay? So here we're gonna write the function countdown, and anytime you do write a recursive function, you should always have a base case that just that will stop it. Otherwise it will run forever, okay? And so we're gonna say if n is less than or equal to 0, this is our base case. We're going to print out the word blast off, okay? Otherwise, print out whatever your n is, and then call this function that we just defined, countdown, call itself, okay? But this time for n minus 1. This time for n minus 1. So I define that function, and then I count down 3. And so the first time it runs countdown on 3, and this is not true. So it executes the else, and it prints out 3, and then it calls countdown with the value 2. And when it calls countdown on the value 2, I guess it does this, all right? Then it prints the value 2, and then it calls itself, all right? And then after it does that, it calls itself with n equal to 1, and then after that it calls itself with n equal to 0, and at n equal to 0 it's going to print blast off, and then and after it does that it kind of ends, it finishes all of these things, and it ends there. Okay. Now I could also just do like print a dot here, and you can see kind of what will happen. So it calls, it's going to start with, so all of these things, it says the countdown they got n minus 1, n equal to 1 returns, countdown they got n equals 2 returns, and the countdown that got n equals 3 returns. And basically after all of those returns, it's printing a dot, okay? So it does, so with recursion, so this part is kind of lost without this additional line, print dot here, but here you kind of see it, right? So you get 3, 2, 1, blast off, and then these things that return all get kind of executed again and again and again. Right. So, all right. So here's another function where we're going to print the some string n times. Okay, and so this is very similar to this countdown function, but we're going to say, all right, print the string s n times. if n is equal to 0, then return none. That will exit the function. Otherwise, print that string and then call print n, this time using n minus 1. So I have that, and I got print hello 3 times, and you can do, you know, hello 6, and it works. Okay. Factorial is kind of like a mathematical example of a recursive function. So, because when you do 4 factorial, it's basically 4 times 3 factorial, and 3 factorial is 3 times 2 factorial, all the way down to the base case. And this is kind of the weird thing that I think sometimes throws people off, is 0 factorial is equal to 1, okay? So here I have, if n is less than or equal to 0, return 1. Otherwise, the value you're going to return is going to be n times factorial n minus 1, okay? And because we're, all of these things are getting returned, it all kind of gets multiplied together. Okay, so factorial 4 will be 24. You know, 4 times 3 times 2 times 1. Factorial 5 gives us 120. And it, you know, I think, I mean, it works, right? So factorial 0 gives me 1. Factorial 1 gives me 1. Factorial 2, we have that. Factorial 3, and so on. Okay, so that's recursion, and recursion is fine. You can accomplish everything with recursion, but it's probably not recommended. Yeah, question?
I'm a little confused with like how the second, like the factorial that recurs, like how is it put in use? Because like the definition doesn't really specify anything. Or is it like a built-in math function? Or?
No, it's not a built-in math function. Wait, the function is this.
Yeah.
When you do factorial, you're going to take your current value n and multiply it by n minus 1 factorial. And that's the definition of, that's one definition of a factorial function, right? So if you do, what is 10 factorial? 10 factorial is 10 times 9 factorial. What's 9 factorial? 9 factorial is 9 times 8 factorial. So the definition of the factorial function is n times the factorial, but at a lower value. And then you just start up, you just have to give the base case, and you say, okay, 0 factorial is equal to 1.
But
0.
how does it know how to do the factorial? Is that in like, is that
The factorial is right here. N times factorial. Like if I did plus, now it's no longer the factorial function. Okay? So this will just be like 4 plus 3 plus 2 plus 1, and then plus 0, and 0 is going to be 1 in this case, or something like that. Okay?
Oh, okay, I see. Yeah.
So by saying factorial is n times something, now it runs this way. Okay? But this is it. That's one way to define the factorial function. Is to define it recursively. Is that okay? Does that kind of make sense? Yeah. So, but you know, it's hard to think of recursion. A lot of times it's hard to think of recursion. It's easier to think of like things as being repeated rather than think of doing something recursively. Okay. You know, so you know, like I don't know, like decision trees and stuff are kind of recursive things, but a lot of times, you know, maybe for loops are just easier to think about, and so, you know, lucky for us, Python has implemented for loops. Okay, and you know, probably most languages have implemented for loops, you know, but you know, there's still some languages out there that are technically like complete languages, but they don't have for loops, that you just have to do everything like recursively and stuff. Okay, which yeah, I think it's hard. Okay, so you know, repetition is, I think, probably easier with like for loops. Okay, and so we'll look at this, right? We're going to look at the for loop, and so here I create a list, and it's got the values 5, 7, 2, and 1. And I just define some value y, and we're going to just run this code, and we're going to say basically for each item in the list, okay? And basically you can run a for loop across any iterable structure, iterable data structure. So, you know, probably your most common iterable structure that you're going to be using will be the list. Well, I don't know the most common, but lists will be in there. Tuples are almost identical to lists, except they are immutable, and we'll talk about that either today or next on Friday. You have things called ranges, which are basically a sequence of integers, and strings are also iterable, which is something that Python does, and it's actually quite handy. And so, but anyway, we'll just start off with this thing. So we say for x and the values, and just like all other code in Python, you use the colon and then you use indentation. And so you're going to just print out that value, and then we're going to take x and add it to y. And so, you know, if you've ever used like C, you're probably familiar with this plus equals notation, but this is the same as just saying y is equal to y plus x, right? So if you just do plus equals, just take y, add x to it, and update y. And then we'll also print out this line that says the running sum is y. So I start off with 5, and then the running sum is 5. And then I take x is 7, the running sum is 12. Then x is 2, the running sum is 14. X is 1, and the running sum is 15. And so that works out just like that, okay? Here is a string, and a string is iterable. And we're going to take each character in this string, we're going to make it uppercase, and we're going to add an exclamation point, right? And so now we get this awkward, cheer, and it takes this space, and it also adds an exclamation point to it. But that's just that downbeat in the 8 clap, right? So, yes.
Is there anything so that print doesn't automatically make a new line after it?
What's that?
Is there a way to make it so that print doesn't automatically put a new
Yes.
line?
So, yes, you do. What is it? Character end. Okay, so let me just again pull up the contextual help for print. Where is it? Okay, so I'm going to click print. Okay, the end is /n for new line, and if you want to change that, okay, so you just do end is equal to, I'm going to give it a dash here, all right, and then now it does that, okay. So the default is a new line character, but you know, if you want a tab, you can do that and stuff like that, right? So however you want to do it. Okay, so that's the for loop, and you give it any kind of iterable, and it will iterate over it. Okay, one of the most common iterables that you associate with a for loop is the range object. Okay, the range is basically it's like a sequence of integers. Okay, so if I do range 10. It's basically the integers 0 through 9. So if in R, we probably wrote 0 colon 9, right? You know, for I and 1 colon 100. And that's probably like a very common thing that you've done. And perhaps your professor said, you know, don't do that because, you know, it's better to use like sequence along or, you know, sequence length or something like that. And that's true. But it's still such a common thing to do, and it's very simple to just like for I and 1 colon 100. Okay. In Python, we do the same kind of thing, except we use the range object. Okay, so we're going to just do for I in range 10, and when you do range 10, you basically get the start, the end, the step size is 1, and it, by default, the range starts at the start value and increments by the step size and goes up to but does not include the end value. So if I do range 10, you're going to get 10 integers, and they're going to go from 0 through 9. Okay, and so if I do for I in range 10, and I just say print I end equals space here, right? So rather then I get the value 0, 1, 2, 3, 4, 5, 6, 9, 9. Okay, I can do range 5 comma 10. Okay, and if you do 5 comma 10, when you run this, it returns the range object, Okay, and that's it. Now you can take a range object, and technically Python doesn't like think of all of the values. So I could say like range 1 million, and Python's not going to be like, okay, 1, 2, 3, 4, 5, 6, and 700,085 and stuff like that. It just says, okay, when we need to produce 785,300, I'll do it. But right now I just know there's going to be like a million things. Now, if you want the values, you can say, all right, no, take this range object and put them all into a list. And when you do this, now Python will say, okay, I'll do it. And I'll list off all 1 million. But it's kind of like instructions for the sequence of numbers. But Python is what we call lazy. All right, and this is like a technical. It's not like we're being derogatory towards Python. Like this is technically how Python is designed, in that it's lazy, in that it's only gonna like think of something and execute something only when it has to. Only when we prod it and say, I need that number now, then it'll say, okay, fine, I'll give you that number, all right? But otherwise, it's going to be like, all right, I know what you want, and I'll give it to you when you ask for it, but I'm not going to give it to you any earlier, all right? And so here, when we say range 5, 10, it says, okay, range 5, 10, got it. And then you say, well, I want those numbers now. Put them in the list. It says, okay, fine, 5, 6, 7, 8, 9, right? And so you can do something like, I'm afraid to do this, right? I can do range 1 million, right? And that's no problem. And I'm afraid to do this because I think this will take a while to. Okay, well, DD to delete command mode. Okay, but yeah, it will do all of that stuff. Okay. Here I've got 0, 20, 2. So this is where things get a little bit, you just have to get accustomed to the way range objects work, okay? But in the beginning, this can feel a little bit awkward, right? So you say, oh, I want from 0 to 20, step size 2, and it goes from 0 and it ends at 18, okay? And then here, if you do 0, 21, 2, then it goes 0 through 20, and it's like, it's not angry that like, you gave it 21, and technically the next thing is 22 or something like that. So this is what you end up getting. It won't let you do floating point, like range only accepts integers as its arguments. So you can't do like 0, 20.1 or something. It says, nope, not gonna do that, okay? You can also specify a negative step size and it will count backwards. So I've got range 10, 5, -1, okay? And all of these things, I've put the range inside a list, which is not normally. You wouldn't normally do this, but here to just kind of let you see what all of the actual individual items are inside the range, I'm putting them in a list. You can put them in a list, and there's no rule against it, but that we don't normally do that, okay? Here, if I do range 10, 5, where the start value is greater than the end value, you're going to end up getting nothing, no values in your range, okay? So here, I would need to specify kind of a negative step size if my start value is greater than my end value. This does not return an error though, okay? So notice that it executes just fine. It's just empty, but it's not an error. So there's a difference, right? There's a difference between code that produces errors and code that doesn't do what you thought it was going to do, right? So a lot of times you can write things that don't syntactically produce an error, but in your brain it's doing something different, and then when you execute it, it doesn't do what you want it to do. And then those are a little bit harder to find because you have to kind of go line by line and say, is this doing what I think it's supposed to be doing? And if you're expecting this is going to produce something, then it's not going to work, right? You need to put in the -1 there. Another kind of loop. Wait, have I given you any view quiz answers? No. Okay. I'll go ahead and give you your first two. D and C. D as in dog, C as in cat. D as in dog is your first one. C as in cat is your second one. D and C. Okay. So another kind of common loop, and again, everyone's taken stats 20, right? Because that's a prereq here. So we all know how while loops work in R, and so here you get the while loop in Python, and it does exactly what you think a while loop should do. Okay, so while it's true, it's going to execute, and then when this condition becomes false, then it stops the code, right? So I guess. So when I have while I is less than 10, print I, and we're going to increment from 0, and we keep adding 1 to I, and at 9, it goes up to 9, and then at the next iteration, I is now equal to 10, and this is false, so it quits out, and that's the end of that. Okay. You have break and you have continue. This is, I think you encountered break and skip or something, or next in R, maybe. Well, anyway, here we can do something like this, okay? So I'm going to say for n in range 20. So it's going to start off at 0, and then it'll do this code, and then it'll do 1, 2, 3, so on and so forth, okay? And here, I give it the keyword continue. So here I have n mod 2. So if mod is like you divide by 2 and what's the remainder, right? So I start off, if I do 9 mod 2, 9 divided by 2 is what? 4, remainder 1. And so the mod is 1. So here I do 9 mod 2, or n mod 2, and if it's equal to 0, right? If there's no remainder, if it divides by 2 evenly, then we do continue. So continue just says, okay, skip the rest of the code, don't read anything else, and just go to the next iteration of the loop. So it starts off at 0, it says, oh, that's true, okay, continue. Now it goes to n is 1, okay? For 1 mod 2, that's false, so then it prints this out and with a space. And then it reaches the end of the loop, and so it goes to the next thing, and it goes 2. And it's this is true, so it continues. And so we end up getting all of the odd numbers printed out, okay? And something like that. All right, here's an example where we can produce Fibonacci numbers, okay? So I'm going to start off with A and B, and I'm going to give it 0 and 1. All right, and so this is kind of like a cool little thing that we can do with, what did I call it? Tuple unpacking. Tuple unpacking, right? So I start off with A and B equal to 0 and 1, and we're going to keep going until A reaches some number greater than 100. Okay, I start off with an empty list. So L is going to be equal to this empty list. And I say, while this is true, so while true runs forever, right? While true runs forever until it encounters break. Okay, so while true will just run forever until it encounters break. And so this is how we're going to do, and no, I'm not going to buy this in-app purchase, sorry. All right, we got, so here we're going to say, here we have this tuple, okay? Or actually on the right-hand side, we're going to take A and B, and then we're going to put the B into the first position, and then we're going to add A and B together, and that will go into the second position of the tuple. And then those unpack, and so B becomes the new A, and then A plus B becomes the new B, right? And if you do this, you'll get kind of the Fibonacci sequence. And then we're going to say, once you figure this out, append this value A to the list. Okay, we're going to take the list and we're going to append A to it. So I run this and we get the Fibonacci sequence here. Okay, so this is kind of a neat little trick. And then I can ask, what is A? Whoops. What is A? A is 144, and what is B? Actually 233. So it went ahead and calculated even the next Fibonacci numbers here. Okay. Some Boolean expressions, because this is important as how it executes the code, right? And so we have, I think this is no surprise. These return true and false. You have the not equals, and you have greater than, you have less than, you have greater than or equal to, less than or equal to, and then and here if I say, is this character or the string 5 equal to the integer 5, and that's false. Okay, those are different. When you do things with, you can actually do greater than and less than for strings, and they do it by alphabetical order, right? So they say, does A come before B? That's true, right? So when comparing strings, it's determined by alphabetical order, and all of the uppercase letters come before all of the lowercase letters, okay? So capital A comes before little a, capital Z comes before little a, okay? Whereas, little a comes before Z. There's also, I don't remember, it gets a lot weirder when, like, you're comparing, like, numerically, right? So, I don't know if your computers are smart enough, but, like when you have them as characters, like, 10 comes less than 2, right? Alphabetically, okay? And so that like feels weird, but when you're dealing with characters and you say alphabetize these, then this ends up happening this way, right? Okay, we have the ands and the ors, and then not, okay? So one thing, for comparisons, you have things like not equals, right? And you're asking, is 5 not equal to 6? And you would use the exclamation point, okay? But when you're dealing with things that are true and false, okay, then you use the word not, okay? So there's a distinction here. So we don't do something like, this is not going to work, okay? All right, so we don't do like exclamation false, right? We would have to write not false, okay? So true and true are true, true and false is false, true or false, true, not false, false or not false, true and not false, and these are these are how your Boolean expressions go, right? This is, I guess, an idiom. This is just one way to check if something's divisible by another thing. So here I've got n equal to 8, and I can say is n divisible by 2 and n divisible by 3, or 6. Is 6 divisible by 2 and 3? That's true. What about 8? And this is, just mod 2 equals 0 is a quick way to kind of check. All right. When you write functions, I recommend going against, unless you're dealing with a very simple function, don't go straight into writing the function, okay? First, kind of write some code in kind of the global environment without putting it inside like a, defined function. Just see if you can get your code to do what you want it to do. And then once you have it working, then you wrap the function inside, encapsulate the lines within a function. So here's some pseudocode. Like if you want to draw a square, just try this out in kind of like the global environment, and you would like go forward, turn left, go forward, turn left, go forward, turn left, go forward, and maybe you would turn left again or something. And then once you say, okay, this is working, then you could then wrap that up inside a function to draw a square. And you can say, well, I had to do this and I repeated it 4 times. So then inside your function, you could then say, all right, go forward and then turn left, and then put it inside range 4, so it'll repeat it 4 times. Okay. And so, you could use a for loop for I in range 4, and it will go through I0, I1, I2, and I3, and you don't actually even have to use I anywhere inside your thing. It's handy to have I if you need to kind of keep track of something, but if you just say, hey, I need this done 4 times, then you could just do for I in range 4, and then whatever lines of code are associated with that will just get executed 4 times. You don't actually have to use this letter I. When defining the for, you do need to say for I in the range. You can't just do for range 4, but yeah, that's what we have here. Okay. Once you have something working, okay, then you can think about like, okay, how can I generalize this using kind of arguments and parameters that will do things, right? So rather than saying I want to, rather than requiring the length of the side being 100 pixels, we can give it an argument, and I can say, let's generalize it so I can draw squares where the length of the side is any arbitrary number, right? So instead of 100, I could say, go 200 or 50 or something like that. And so now we've got some generalization, right? And right now we're doing this 4 times, and we draw a square. What if we wanted to draw other shapes, right? And so we say, okay, well, how can I generalize my function so it can draw other shapes? And so this is where you start to try to do the thing, but you want to try to look for patterns, right? So if you wanted to draw, say, a pentagon, how much of an angle do you turn, right? And so basically, if you're drawing a shape, at the end, you're going to end up going around 360 degrees, right? So if I start here and then I want to make, 6 turns, each turn is going to be, 60 degrees or something, or if it's 5 turns, are you okay over there? All right. Hey, let me have you sit down, okay? Is this not working? Okay, sorry. Yeah. So here with a pentagon, how much you turn will be 360 divided by 5. With a hexagon, it'll be 360 divided by 6. And how would your code change? Well, with a pentagon, we would have to repeat ourselves 5 times. With a hexagon, we'd have to repeat ourselves 6 times. So we look for things and we say, okay, you know what? The angle is going to be however many sides I want. It's going to be 360 divided by n. And how many times do I have to repeat myself? It's going to be n times, right? And so if we wanted to kind of generalize to, say, drawing a polygon, why do I have a T here? Okay. Sorry. Okay, just polygon with n sides, and each side has a certain length, then it'll be the angle is 360 divided by n. Okay, and then for I in range n, we're going to go forward the length, and we're going to turn left whatever this angle is. Okay, and so that's how we would go about drawing this. Okay. Okay, so I got just a few minutes left. I'll go ahead and give you your last view quiz answer, and we'll start talking about lists, and we'll have to continue this on Friday. The last view quiz answer is the letter E. E as in elephant. E as in elephant will be your last view quiz answer. All right, so you create lists with square brackets. So here, this is a list that we're making up. We have people's names, and we're going to call this our family, fam, and we've got names, and we have numbers. So fam has Liz, 1.73, Emma, 1.68, mom, 1.71, and dad, 1.89. I think these are heights in meters, okay? Now, lists can contain mixed types of data. So I have strings and floats in this list, and that's fine. And you can mix in any kind of data things. You can have lists nested inside of other lists. So here I have a list. The top level list is length 4, and within and the elements in this list are each lists themselves of length 2, right? So I have a list of 4 lists, each of those length 2. Okay, and this is how the lists get printed out, and we can tell they're lists because they have square brackets. And you can also ask, what is the type on this? And it comes back and it says it's a list. Okay. You can subset a list using square brackets, and you would use a square bracket and the integer, and everything is 0 indexed. Okay, so the index starts at 0, and that's something that like hard to get used to in the beginning, but you'll get used to it. All right, so here if I do fam square bracket 0, it comes back and it says the first element in there is the character string Liz. Okay, and if I say, okay, what's the first element in fam2? The first element is the list Liz, comma 1.73. And so when you have lists nested inside of each other, then you can recursively subset, and you can say I want the zeroth element in fam2, and within that I want the 0th element, 0 index element, and that will be Liz. Okay. You can also use negative numbers when you are subsetting, and this counts in from the end. So the last number, or the last value on the list, -1 is 1.89, -2 is going to be dad, and so on and so forth. Yeah. So fam2 -1 here, it comes back and it says this is the last element in fam2 here. Okay, and again the recursive subsetting works out this way as well. Okay. That's right. That's who I am. Okay. List slicing. Okay, so if you want to select multiple elements within a list, you can do you can specify kind of 2 integers separated with a colon, right? And this will slice from 1 to 3. Now, one way, the way I like to think of it is the slicing basically takes places at the commas. Okay, so if I slice from the first comma that appears here to the third comma, it's going to start at 1.73 and include Emma. Go up to Emma and end there, right? So 1.73 Emma, and this is what we get. Okay, 1:2 will slice from the first to the second comma, and it's going to pull out the number 1.73. Okay. If you don't put in a colon, you'll just get the value at that index. 1.73 will be the 1 indexed value, the second element in the list. And if you do use a colon here, and you do fam1:1, okay, now you're like slicing from the first comma to the first comma. It's going to return an empty list. There's nothing there, right? So if you want the first 2 elements, you would slice from 0:2. So you kind of think of like the zero index comma or something. It's not there, but you can do that, and it'll give you the first 2 elements. You can do from 6 to 8, and it'll do that. You can also, you don't have to specify a number after the colon. So you can do 2:, and it will get everything from the second comma on. You can do :4, and it will go up to the 4th comma. Okay. And if you do just empty, you do fam blank : blank, this will just produce a copy of the list. Basically, it copies the entire thing. But if you specify square brackets and you don't put anything in there, this gives you an error, right? It says, I'm expecting something here. Okay. I got just a couple more examples of this, but I think you can kind of look over this. I'll we'll start with lists are mutable on Friday. So we'll end here for today. So we'll see you all on Friday. Have a good day.